Okay, so we can see from that this wide range. Now remember, everything here is light. It's all light from the radio to down here to gamma and X-rays. So we're going to put on our little diagram here in your notes, the same one in the book, but we're going to have some information up here. So here, frequency about 10 to the 4th hertz. We also have up here, we're also in the 10 to the 4th meter wavelength. So up top here will be our wavelength. 10 to the 4th meters. Now we're not really using these wavelengths. Now we start getting into some of these that, this is like 10 kilometer waves. But we start getting into some of these areas on here, 10 squared, 100 on the 10 squared area. But somewhere in here, with the Navy does use some communications here. It's how they talk to submarines. Can't get voice, but it is data on that. About here is AM radio. This would be our AM radio, is in these frequencies. We start getting into the meter range here. 10 to the 0 power, which would just be 1 meter range, that 1 meter range. So we're down here. Here's like FM radio and TV, kind of goes both ways. We're on TV here in that area. We start getting into our microwave region, our 10 to the 10. So this would be 10 to the minus 2, what we call centimeter waves. Centimeter waves, those are our microwaves. This is where you're going to find things like your cell phone. Cell phone, this is like voice, a lot of voice, radio, things like that. Satellite TV, satellite communication is done in that range. We start getting into the infrared range. We're starting to get 10 to the minus 4th meters. In here, those would be all the types of infrared light, heat lamps, things like that. We have this little bit right here, basically 750 nanometers to, this is 10 to the minus 6, 750 to 400 nanometers of range. These are our Roy G. Biv colors. Very, very, very tiny, tiny, tiny on here. So 4 times 10 to the 14th hertz. 7.5 times 10 to the 14th hertz. So this very, very narrow band, and this is what we can see. We call it light. That's visible light. That's the only light we can see here. We get down to here, the ultraviolet, the 10 to the minus 8th. Near ultraviolet, we use, that's like what you get suntan. That's what gets the atmosphere. The very high ultraviolet frequencies, like we use in the goggle sterilizer, we don't get their atmosphere. Our atmosphere blocks that. We get down here about 10 to the minus 12th meters. 10 to the minus 12th. X-rays and gamma rays, they overlap. They're very similar in their frequencies and energies. We have 2 different names because of where they come from. X-rays come from the electrons, just like all the other light does, excited electrons, things like that. They drop from an energy level, spit out an X-ray. Gamma rays, although similar frequencies, they are produced by the nucleus, because the nucleus gets energized usually because of something like a nuclear weapon or nuclear fission goes on. It energizes, puts lots of energy in the nucleus. The nucleus doesn't want to keep that energy, so it spits it out, and it spits it out in the form of gamma rays. I have this little thing about the EM spectrum.
everything that the human eye can see. The importance of this frame is that the stars emit almost all of their light at this angle.
Even though the light is visible, it still contains hidden tools. The secrets are in the spectrum itself. The visible light in this lamp comes from hydrogen gas excited by electricity to form a glowing plasma, similar to what happens in nebula. By viewing the lamp through a diffraction grating, we can split the light up into 3 narrow lines of the spectrum, a virtual fingerprint of light, unique to hydrogen alone.
So in the spectrum, we see 3 features. Red, one is a light blue, and the other is a deep blue. This pattern of wavelengths is absolutely unique to hydrogen. There's no way to confuse hydrogen in the spectrum with any other element.
All right, so we can see from this the different things about the electromagnetic spectrum. There are different qualities of the electromagnetic spectrum here. So as you can see, and we'll talk about visible light in chapter 28, but it's a very, very, very tiny part of what we can see. This is one of the things I want you to get out of that, is that visible light is one of very, very tiny. So that's it for this lecture on that.